I'm Anne Riddell, and this is Science and You. Technology has shaped the cultural fabric of humanity since the invention of the wheel. Today, we explore some of the most exciting modern technologies that will once again change the way we live. Take our homes, for example. There was a time when your house was nothing more than four walls and a roof. Now, it's a 24-hour personal command center.
I'm Donna Hanover. With a connected home, you can turn on the lights, unlock the door, start the music, raise the temperature, and even see pictures of anyone waiting on your front step, all using your smartphone.
Dan Levine, CEO of CytexOne, has helped many people turn their dwellings into smart homes. The screens in your house and also on your mobile devices show the options that have been programmed so you can operate things with a couple taps, whether you're at home or miles away.
And then you can choose either watch, listen, lighting, the comfort, or security. Say I wanted to adjust the thermostat and I wanted to turn it off. I would just click off and it turns off.
You can be 1,000 miles away and this can work.
Absolutely.
Security is important to lots of smart home fans.
On a traditional security system, when the alarm goes off, it will just notify a central station. With this type of system, it could actually send a push notification to your cell phone or your iPhone.
You get a text.
You get a text, or it pops up right on your screen and you see something's going on in your house. You click it and then you can instantly view the cameras.
And if it's someone you want to let in?
There are numerous doorbell applications that we use where you press the doorbell and it'll pop up with a notification on your phone or your iPad that somebody's at your door, and you could press a button and see them and even open the door to let them in.
Connected homes are possible because of the Internet of Things, the concept that more and more items in our lives are built embedded with electronics, software, sensors, and network connectivity, which enables these objects to work together. Our laptops and phones and audio speakers have been using mostly Wi-Fi and Bluetooth to communicate. An exciting wireless development is Zigbee and Z-Wave mesh technology.
Mesh technology allows every device to be both a receiver as well as a repeater. So as you add more devices, traditionally, as you add more of something, things slow down and get worse. With mesh, as you add more, it strengthens it. This is a Zigbee remote control. So when I'm pressing the channel or volume button, it could be bouncing off of a lock or a light switch to get back to the brain of the system. It's a phenomenal technology.
Smart homes can save energy and resources.
So there's numerous systems that automatically detect when it rained, either by sensors or by tying into local weather stations, and it can automatically not water the lawn.
Some people like what are called scenes, where lots of things happen with one touch.
You can have a dinner time scene that may bring the lights down in the kitchen and may bring the lights up in the dining room and start very light music playing. You could have a goodnight scene that turns off all the lights in the house. It will bring the shades down, it'll lock all the exterior doors, could arm your alarm system.
Smart homes can help with child rearing.
Baby monitors are important to quite a few, especially new parents. Traditional baby monitors, they only work within a certain distance, but using an internet-based camera, an internet-based baby monitor, gives you the advantage of being anywhere and seeing your baby. And there are some systems that you can actually speak to them and speak to the baby or speak to the nanny that's watching the baby.
And when the children get older,
we set up a wireless network that's just great for kids, and it protects them from websites that might have adult material or content that might actually infect their computer with spyware or viruses. Have the kids stop watching TV or do their homework. Being able to press a button and disable the TV in the kids' bedrooms.
Of course, that's not going to actually make them do the homework.
Probably not, no.
Various companies create these devices and technologies: Control4, Nest, Netgear, Lutron, August, and others. Can a do-it-yourselfer connect a home to the internet? Or is that a potential disaster?
We've actually gained a lot of customers like that they go and they buy a lot of this technology, and then the husband or the wife, either or, want to just throw everything out or just go back to the old days when you had to get up to change channel because nothing works in their house. But if you want just a lock or just a doorbell or some basic lighting, it's definitely something that's doable on your own.
Having a connected home can solve a classic problem.
When you leave your house, how many times have you said, oh no, did I forget to lock the door? So what you can do with something like this is you bring it up the app on your phone and you could see, oh, the lock, it's unlocked. Oh no, I forgot to lock it. So you can actually just click the button and it will automatically lock the door. Very simple.
So whether you're a do-it-yourselfer or someone who lets the professionals take over, you can install amazing technology to keep you and your home comfortable and secure, all controlled by a device that you're carrying with you anyway. I'm Donna Hanover for Science and You.
Imagine being ill and needing a diagnosis, or maybe you want to know your blood type, but there isn't a doctor around for hundreds of miles. Mike Gilliam came across a way those questions might be answered through your iPhone.
Advances in technology, including the smartphone, are playing a major role in how medical services are now delivered. In fact, researchers here at Columbia University have come up with what they're calling a life-saving blood app that actually plugs in to a smartphone. This is the dongle created by Dr. Sam Sia, an associate professor of engineering at Columbia, and his team. It can be used to do blood tests far away from a hospital or the lab at a fraction of the cost of laboratory tests.
We call it a smartphone dongle or an M-chip smartphone dongle. The way it works is you would prick your finger and get a drop of blood. So instead of having people drawing blood from your vein, you would just prick yourself like diabetic patients do, and put that drop of blood onto this device here, which fills the tube, and snap it into the chip, and the chip goes into the reader, and this dongle here would then produce the result in conjunction with the smartphone. What we've shown is that we can use it to test for HIV and syphilis, so sexually transmitted diseases. We've done testing in sub-Saharan Africa, in Rwanda, to show that it works on the infectious diseases over there as well, but in theory we can do a lot of other things. This panel of tests called immunoassay, so it could go from cancer markers to some cardiovascular markers, basically any protein markers. So a lot of other tests we can potentially do as well.
It has already been tested in Rwanda by Sia and his team, including PhD student Samiksha Nayak. In the lab, she pricks her finger and demonstrates how it works.
So I have a finger prick of blood ready, and I use the first of our two plastic microfluidic components. The first one is to collect the blood. So I just collect it, and that's all we need to run the test. And then we attach the other plastic component together, and now we're ready to run the test. And as the app instructs, I'm going to press down on this vacuum bulb, and this is what drives all of the fluids through the cassette, so both the blood sample and all of the reagents that are contained.
Then the operator follows the instructions on the smartphone until the results are known in about 15 minutes.
The result can be displayed to either the doctor or the patient right there within that same visit. But because we're using this in conjunction with a smartphone, the information can also be synchronized with the patient health records up in the cloud as well. This is the future, and this is really where a lot of us think medicine will invariably go.
The move towards digital health is already underway, with consumers using apps and other electronics to monitor their health. But Dr. Sia says devices like his could transform medicine.
You can see medicine being delivered in people's homes and pharmacies instead of having everything being done in hospitals where it's very expensive and very inefficient.
This is very important in places like Rwanda, where undiagnosed cases of syphilis and HIV can be deadly. Samiksha Nayak traveled to Rwanda and took part in the field trials. The device was taken to rural villages, and they say it provided very accurate results using the battery power from the phone.
It was an incredible experience to be able to see this being used in the field and to see something that you've spent a lot of time working on here in the lab actually being implemented. I think that's something that not many people get to do in their PhD career, so I'm really thankful to be working in a lab like this. They were definitely interested in the device and its capabilities, and especially the ability for mobile outreach and sort of going on more mobile health visits.
In addition to mobility, there is also the issue of cost. The robot used to do blood tests in the lab can cost thousands and thousands of dollars. The cost to make the dongle is $34. Each test also requires the chemical diagnostic chip. But in the end, they say, each test costs about $40 or $50 at the hospital, and they hope to do the same test for about $10. Now, researchers say devices like this dongle and others are still in their infancy stage. So where will all of this go over the next 10 years?
Well, it's going to be a very exciting time in the next 10 years when we start seeing the kinds of tests that your doctor might be interested in.
Like ultrasound?
Like ultrasound, not just blood tests, but ultrasound, things that they really look at. They're not looking at the number of steps you take or things like that. If the kinds of things that they're interested in are now start being offered to the consumer on a more frequent basis, we can actually get these measurements taken more frequently. That's when you're going to see the healthcare system being transformed. We're going to see preventive medicine being much more powerful.
I'm Mike Gilliam for Science and You.
Technology enhances our ability to navigate the world around us, but the latest trends in wearable tech could give us a better understanding of our own bodies from the inside out. Andrew Falzon has more.
They started out as glorified pedometers, counting your steps while you counted your calories, syncing with your smartphone, uploading your data to the cloud, and labeled with cute names like Fitbit. Next came smart scales, allowing you to step on so it could keep meticulous notes about your weight and body fat, but the newest generation of wearables is tracking a lot more than that. This digital rock is called Spire. In addition to providing typical activity tracking features like steps and calories burned, it also tracks your breathing. The lower your respiration rate and the more even your breathing, the more relaxed you are. Spire also provides instant notifications to your phone, reminding you when you need to slow down, but sometimes you need to pick things up. The Lift from Lumo is a magnetic pendant that clips onto your clothing. Using internal sensors, it monitors your posture and gently buzzes and notifies your smartphone if you're not in proper alignment. It also tracks traditional metrics like steps and calories, but for hardcore gym rats, a brand new brand of fitness apparel is taking personal training to a whole new level. Athos is an advanced fitness monitor with sensors built right into form-fitting athletic apparel. The whole system consists of a compression shirt and shorts. A digital core plugs into each and processes the data picked up by the clothing and then sends it to the Athos smartphone app. The company provided us with a complete set of gear that I tried out under the watchful eye of physical therapist Dr. Jeffrey Espinoza, who has trained elite NBA and Olympic athletes, and now he's trained me.
Alligator walks. I'm dead.
We both approached our non-scientific, informal Athos test with an open mind. Inside the Athos clothing are electrical pads like you'd find on an EKG machine at the doctor's office. While the setup we demoed costs about $700, it's far more portable and affordable than the $15,000 electromyography machine it would replace. Back at the gym, we went through a series of exercises that are the staple of any routine, including squats, deadlifts, and push-ups using little or no weight, putting both technology and reporter to the test.
In terms of like a trainer or somebody who wants to use it in the gym atmosphere, it's definitely good enough for sure to pick up on certain things, just in general what you want to use.
While the clothing seemed to accurately detect muscle activation, it was Dr. Espinoza's instructions that ensured I was using the proper muscles and proper technique, and while the app was easy to use, logging a workout proved to be a bit challenging. But future improvements to the Athos app could bolster a very impressive piece of gym hardware.
This is something that can really help people if, again, depending on the person, if you care enough to learn about it and learn how to use it.
Wearable devices are also now being used in medical applications. This is the Vital Connect Health Patch, and while it may look like little more than a bandage, it's actually a complex health sensor capable of monitoring heart rate, respiratory rate, skin temperature, posture, fall detection, and it's also able to act as a single-lead EKG, which can detect arrhythmias. Also on the horizon is this flexible hydrogel bandage developed at MIT. It's able to host a variety of electronic sensors and drug delivery systems, all while taking the shape of the body part it's covering. it's still in the research stages.
So whether you're heading to the gym or to the doctor's office, hopefully one of these wearables will help you better meet your goals. I'm Andrew Falzon for Science and You.
Throughout the years, Beth Kovetz has brought us stories about 3D printing. This time, she sits down with John Arzeus, who started an ambitious project, a 3D printing microfactory right in his own apartment.
I'm Beth Kovetz for Science and You. Over the years, we've brought you various stories about developments in 3D printing.
We spoke to MakerBot founder Bree Pettis before MakerBot was a household name.
If I could travel, if I could send this back in time to myself at age 10, the world would be a different place if just one MakerBot had been delivered to me when I was 10.
We checked out NYU's cutting-edge machines and looked at what 3D printing has meant to medicine and amputees.
I can pick up stuff.
Today we're going to take a look at what 3D printing means for New York City, because not every exciting piece of technology comes out of California.
MakerBot was born 7 years ago in Brooklyn, and through a grant from the New York Regional Economic Development Corporation, Dutch company Shapeways moved its headquarters and factory to New York and is now a major player in Long Island City.
What is Shapeways?
Shapeways is a service that enables everyone to make whatever they want.
And now, changes in technology are making 3D printing readily available to all New Yorkers.
Hi, Beth.
Hi, John.
Welcome. Come on in.
Thank you. So, John, this was once your two-bedroom apartment.
That is correct. When 3D printers were first built, they used to be very large and take up whole industrial spaces. Now, with modernization, a lot of the machines have gotten very small. You can fit them in a two-bedroom apartment even.
So let's go check out what's happening in the master bedroom.
John's got a G-Max X1 XT. There's MakerBot replicators, the Stacker 500, all tucked into this little space. John explained to us that, as expensive patents expired, communities like RepRap have driven down the cost of 3D printers by using readily available parts like Arduino and Blu-ray style lasers.
In this 425 square foot two-bedroom apartment, the Microfactory also has the cutting edge of 3D printing technology.
This is the Pegasus. This was a stereolithography printer, also known as SLA printer. And how stereolithography works is that it uses a liquid resin and it uses a laser to solidify that resin and build a very high resolution model. Since it uses a laser, photons are much smaller. So and then you can use that to create very high resolution. Back in its inception, we had $10,000 laser beams. Now we're down to just a few dollars.
That's amazing.
Drives the price down and also makes everything smaller. Back in the day, you had a laser that was about 14, 15 inches long. And here we had dealing with a laser that's about the size of a little pen flashlight.
3D printing is also scaling up. Larger machines are creating larger output. The same technology we see in use in the Microfactory is being used to create extraordinarily detailed things as large as buildings.
Why 3D printing?
Because there's no 4D.
Well, actually, just last month, a team of scientists at Harvard University revealed their 4D printer created by using hydrogel composite programmable ink that changes structure over time.
Do you think that 3D printing is good for New York City?
I think it's great. It builds up entrepreneurship. When I started with 3D Hubs, in this neighborhood there was maybe 6 other shops. Recently I checked and there's nearly 100 new shops in this area.
Who are your clients?
It's a combination of different types of people. I'll get inventors, I'll get makers, some moms who like printing up little toys for their kids. I get a lot of that actually. And also artists and sculptors.
John, do you think the city's large per capita population of brainiacs and artsy-fartsy makes New York City particularly interesting for 3D printing?
Yes, I think that's exactly what's making the city so exciting. Every day there's new people coming in, new artists, new engineers, new scientists, and they're always calling the Microfactory, calling me to help them out with these ideas. I have the technology, they have the ideas, we bring it together, and we come up with some great stuff.
That's so fantastic. John, thank you so much for your time.
Thank you, Beth.
This has been Beth Kovetz for Science and You.
Do you ever get tired of slow internet as the result of too many devices clogging up your Wi-Fi? Well, Ari Goldberg has seen the light. New technology that might make sluggish internet a thing of the past.
We're here at the Photonics Lab at City College, where behind these doors, they are working on the next steps in internet technology. It's not Wi-Fi, it's Li-Fi.
Idea of communicating with light itself is not new. Think of smokestacks, right? I mean, that's a good example of a visible communication. So visible light communication has been around for so long.
Professor Vinod Menon is a physicist in the field of photonics, the science of generating, manipulating, and detecting light.
Li-Fi stands for light fidelity. But what it really is communicating between your computer or your handheld device and the outside world using light as the medium that sends that data to your device.
The current setup most of us are familiar with, of course, is Wi-Fi, which uses radio waves to transmit data.
The problem with Wi-Fi is because it's radio frequency, you're limited in bandwidth, and there's so much Wi-Fi being used. For example, if you're sitting in Bryant Park and trying to access the Wi-Fi there, it is extremely congested.
But why are radio waves more limited than light? First, it helps to understand how we transmit data in the first place. When we download a movie or type in a Word document, all of that data the computer reads as just a series of ones and zeros. What we read as an email, the computer reads as this binary code. The larger the item, the larger this binary code of ones and zeros. Visible light happens to be able to move that data faster.
If you use Li-Fi, for example, where there's a much higher bandwidth, each person has much larger bandwidth accessible to the person. So which means the congestion is not happening. To put a number, it's about 3.5 gigabits per second as compared to your wireless router, which is in megabits per second. Like, it's about a factor of 100 improvement that you can easily get.
Radio and light are both types of electromagnetic waves. So are infrared, microwaves, and X-rays. Transmitting data is all about using electromagnetic waves to act as our binary code. For instance, a pulse of a light wave could equal 1, and a break in that wave could equal 0. So what do we have here?
So what I have here is a small demo that sort of explains the physical principle of Li-Fi. We have here a red laser, and I have something called a chopper, which chops this beam of light. So coming out of the laser is a continuous stream of photons, and then this chopper is chopping it up. And so if I look outside here, you can see this thing flickering.
Yeah.
And that's your ones and zeros right there.
Light is a higher energy electromagnetic wave than radio, and that means it has a higher frequency. That is, its waves cycle through at a much higher rate. And a higher rate of waves equals a higher rate of data. But we've had light forever. Why is Li-Fi only coming on now? The key is using a different kind of light bulb, LEDs.
Suppose we replace those fluorescent bulbs with LEDs. And these LEDs sitting next to them had an on-off switch, which could turn them on and off at really high speeds. Then what these LEDs are doing are turning on and off really fast, but our eye doesn't perceive it, so our eye still sees this room being lit up uniformly. But your computer has a sensor that detects the fact that there is this LED that is blinking at really high speeds. Those high-speed blinking is actually your ones and zeros, your data that is coming down. And that's how you download your movie that you want to see.
Our current incandescent and fluorescent light bulbs can't turn on and off fast enough, like the LEDs. But the great potential of Li-Fi is that the infrastructure is already there. Eventually, specialized LED bulbs could go right where our current lights are. I guess in an ideal world using Wi-Fi, you just walk into a room, turn the light switch, and that's your internet connection.
Exactly. And also you can ask the question, if I need to use Li-Fi, do I need to have the lights on in my house all the time? And the answer is no, you don't, because you can actually dim the light, and even with the dimmest light which is not perceivable to our eye, you might be able to send the data.
Li-Fi isn't set to dethrone Wi-Fi just yet, but the first real-world office and business uses have already taken place in Estonia, and speeds have indeed reached over 100 times faster than Wi-Fi. The question now is, just how fast can it go?
Wi-Fi typically relies on megabits per second. The Li-Fi speeds have been predicted to be gigabits per second. So if you can make those LEDs run faster, then that's a way to get higher data speeds. One of the things we are working on in my lab is how can we make LEDs turn on and off faster.
As photonics technology advances, we can expect to see Li-Fi in our lives in the coming years, and with it, a much faster World Wide Web. For Science and You, I'm Ari Goldberg.
Cats have captivated us for generations, seeming affectionate one minute and indifferent the next. More recently, cats have become internet sensations, transfixing online audiences across the globe. We close today's half hour with a closer look at how technology has fueled that feline fascination.
You used to call me on my cell phone.
From the ultimate cool cat
to the surprised kitten who melts us with off-the-charts cuteness. For many, cats are something of an internet obsession, garnering thousands upon thousands of likes and shares. How Cats Took Over the Internet, an exhibition at the Museum of the Moving Image, takes us inside that online phenomenon. Jason Epping, curator of digital media, explains some of the early timeline. When did cats and the internet become a thing?
Yeah, I mean, I would point that to 2005, 2006 with lolcats and Catterday. A lot of this is sort of just like, it's not about the cat, it's about the gesture of posting the cat. It was less about, look at this cat, and it became more about, look at me posting this cat. And the cat sort of became a signifier for someone who sort of like was in on the joke.
As people, our enchantment with cats dates back centuries, long before technology gave rise to famous felines. One of the first celebrity cats, notoriously finicky Morris.
The castle's almost finished, Your Majesty.
Good. Reserve the dungeon for yourself.
Morris was a spokes cat for 9 Lives Cat Food, and it really embodies one of the ways that we think about cats, which is like really, persnickety, really, thinks he's better than everyone else. And that's one thing I think that we often impose on cats, that we think that they're thinking that they own us, we don't own them.
Maybe they do.
Right.
The exhibit examines today's larger-than-life cat personalities. For example, wildly popular Grumpy Cat, whose frown made her famous.
Grumpy Cat seems to have this perma-scowl, and it's really funny. And Grumpy Cat's owner has parlayed that into an incredible career of licensed merchandise, a movie, books, all these sorts of things, and people love it. People love Grumpy Cat.
But this is much more than just funny videos of cats. The exhibit raises deeper questions about how we see ourselves and our culture through the lens of what we choose to watch and share. One recent poignant example of that occurred after the Paris attacks. Belgians facing a terror alert flooded Twitter with cat images, using humor to combat fear in a powerful show of unity.
I think it was really telling that people responded with cats. It was an effort to diffuse the situation. It was an effort to sort of try to take ownership or take control of something that was otherwise really terrifying. I think it was a real insight into how we comfort each other online.
The exhibition offers a clever explanation of anthropomorphism, meaning when we give human traits to non-humans. In this interactive section, visitors can use magnetized words to describe what a cat is feeling, with hilarious and revealing results. Consider this: confused, lazy, sad. Is it us or the cat?
We can see a cat responding in a certain way, and we think that they're feeling the same way that we would feel if we were sort of responding the same way. And certainly cats do have emotions, but they're not as complex as ours.
Though there are any number of reasons we might find cats irresistible, one of those reasons may be rooted in science.
And there's lots of research that goes back for decades that says interacting with animals is good for you. It increases your happiness, it helps with stress and anxiety and depression. And new research actually shows even watching videos of animals can have some of those same effects.
And finally, because I just had to ask, are you a cat person?
I'm not. I'm allergic to cats, and also I don't really like them.
So you're kind of the perfect person to do this.
Yeah, no. I'm coming from a very objective perspective. I have no skin in the game.
Since I left the city, you got a reputation for yourself now. Everybody.
And that's our show for today. Join us next month for an in-depth look at disease and disability and how DNA might be the cause or the cure. I'm Anne Riddell. Thanks for joining us for Science and You.